Today we start Chapter 5. Chapter 5 is really important because it's the foundation for all mathematics. It doesn't matter if you're doing kindergarten arithmetics or higher level calculus, differential equations. The foundation is built on the content covered in Chapter 5. So let's begin with divisibility rules. This is a quick review. Here is a set of questions. Question 1. True or false? All integers can be divided by 1 and the number itself. Whenever I'm asked questions like all integers, all natural numbers, all whole numbers, I like to think about the numbered line. So obviously you have 1, 2, 3, 4, so on and so forth on the right-hand side. On the left-hand side, I have -1, -2, and in the middle, I have 0. Now, there are a couple of special numbers. We know that a lot of the special cases are evolved around 1, 0, or -1. So generally, if I think all integers, so if I pick any number, I pick 4, 4 can be divided by 1, yes. And 4 can be divided by itself, right? So that seems, on the surface of it, this statement seems to be true. So seems to be true. That's my first impression. But then let's look at some special cases. What about 1? 1 divided by 1, and 1 can be divided by itself, which is also 1. 1 works. -1 works. It's all looking promising. What about 0? 0 can be divided by 1 because 0 divided by anything is 0 itself. So 0 divided by 1 is okay. But 0 divided by 0, remember, there is nothing we can do. You cannot divide a number by 0. Therefore, this is not true because this cannot be true. So the answer to this is false. B, all even numbers can be divided by 2. So in other words, 2, 4, 6, 8. Let's look at some of the bigger numbers, 1,006. All of them may be negative on this side, -1,000. All of these numbers can be divided by 2. 0 can be divided by 2, even though 0 would be right here, even though 0 is not considered an even number. So in this case, we say this is true. Okay. Gets a little harder. 5, 10, 15, 20, 50, 1,005, 78560, 2, 3, 4, 5. Do you see the pattern in this? Look at these endings. All of these numbers end in either 5 or 0. So the pattern is that all numbers above end with 0 or 5. And therefore, all of the numbers above are divisible by 5. So if you want a number to be able to be divided by 5, that number has to end by 0 or 5. So the divisibility rule here is what I just said. All number divisible by 5 has to end with 0 or 5. This probably is the hardest, the divisibility rule by 3. So take a look at this number. 3, 9, 12, 27, 48. These look familiar. But look at the bigger end. 792, 981, 801, 12561. So all of these are intimidating numbers. It don't seem to be that friendly. But if you look at it, if you add the digits together, 2 plus 1, 2 plus 7, 4 plus 8, 9 plus 1, 1 plus 2 plus 3. If you add all the digits together, we have something. Let's see, this is 12, this is 18, this is 15. Even if I add my largest number, 1 plus 2 is 3, 3 plus 5 is 8, 8 plus 6 is 14, 14 plus 1 is 15, and this one is 9, this one is 18, this one is 18 as well, this one is 15. So when I add all the digits together, the sum of these digits, meaning these numbers in blue, are divisible by 3. 3 is divisible by 3, 15 is divisible by 3, 18 is divisible by 3. Therefore, these numbers are divisible by 3. So the divisibility rule for 3 is that if the sum, meaning you add it together, the sum of all the digits is divisible by 3, then the number is divisible by 3. Doesn't matter how big the number is. You just add all the digits together. If the sum can be divided by 3, you are there. Okay? Finally, the last one, I just want to point this one out. It's pretty obvious. 11, 12, 33, 44, 55, 66, 78, 77, 88, 99, at least everything up till here before 11, when you have double digit of a number, that's all divisible by 11. Anything greater than 100, like 121, you do have to use a calculator and give it a try. Okay? So that's divisibility rule. Please go to the assignments and finish your practice. And we went through this a couple of days ago, about 2 weeks ago. So explain to me, how do you find GCF? And I can tell you, if I use my red marker here, these numbers, as you can tell, these numbers are GCF. And my big L, my big blue L, that includes all the numbers in the column and all the numbers in the last row, is my LCM. So in the space given below, please explain to me, how do you calculate GCF and LCM? Okay? Thank you, guys.